Hi folks, today we are going to be learning how to calculate the distance an object travels when it accelerates from an initial velocity that is not zero. Last lesson we learned how to calculate the distance an object travels that is accelerating, but today we're going to be looking at it from the perspective of what happens if it's already moving when it starts to accelerate. Let's dive in. So first things first, the equation that we are using in today's problem is the exact same equation that we used in the problem from class on Wednesday. The distance an object travels is equal to the initial velocity times the time plus 1/2 the acceleration of that object times the time that object is accelerating squared. Okay, in this problem we have a car that is going through a stop sign. And it has a rolling stop, where the car is technically still moving as it passes through the stop sign. The car then proceeds to accelerate at 4 meters per second squared for 3 seconds. How far does the time travel in this amount of time? So one thing that I encourage you guys to do whenever you're tackling on a problem in physics is to draw a picture of that problem, because that can help us understand what our initial variables are and help us understand, okay, what terms do we know? What do we not know? How are we going to use them into the equation? That type of thing. Okay, so let's dive into this particular problem using the if-SMU method. We first need to identify what we know and what we don't know. What terms, what variables do we know in this problem? We know a couple of different things. We know that the acceleration is 4 meters per second squared. 4 meters per second squared. We also know that the car has an initial velocity, and this is the piece that we're adding in our video today, is that in our previous problem, the initial velocity was just 0. And we also know how long our car was accelerating for. It was accelerating for 3 seconds, so we know the time as well. But unfortunately, we don't really know the distance. Cool. Do you guys remember what formula we can use to solve this problem? If I know the acceleration, initial velocity, and time, what formula can I use to calculate the distance the car travels? It is x equals VIT plus 1/2 AT squared. Go ahead and see if you can substitute the terms into this problem. When we substitute our variables, acceleration, initial velocity, and time into this problem, what does it look like? You should get something that looks very similar to what I am presenting right now. The distance the car travels is equal to the initial velocity times the time it was traveling for, plus half the acceleration times the time squared. Notice how when I'm squaring the time, I'm not just squaring the units or the numbers, I'm squaring both. Okay. From here, it's just a matter of doing the math itself. I did my math in multiple steps. I encourage you guys to try and do the math steps on your own and try and figure out what the correct answer is with the correct unit. So see if you can finish the remaining 2 parts of this problem and tell me what the answer is and what are the units for that answer. Good luck. Okay, let's see if you did the problem correctly. 3 times 10 meters per second, 3 seconds times 10 meters per second are seconds. They cancel out, so we can kiss those goodbye. And we are left with 30 meters. 1/2 times 4 meters per second squared is just 2 meters per second squared. And 3 seconds squared is just 9 seconds squared. Like that. When we multiply 2 times 9, our seconds squared, they cancel out. And we are left with 2 meters times 9, or 18 meters. And then it's just a matter of adding 30 plus 18 to get our final answer of 48 meters. There you go. Cool. I'll catch you guys on Wednesday. Have a wonderful rest of your week. Bye.